let's look at encapsulation. We start with the meaning of the word encapsulation, and as written, encapsulation refers to bundling of data with the methods that operate on the data or the restricting of direct access to some of the object's components. Encapsulation is used to hide the values or state of a structured data object inside the class, preventing unauthorized parties direct access to them. It's a lot of words and it seems like a very pretty complex definition, but all it means is that as you go about defining the classes, we have seen it's kind of a complex data structure which has attributes as well as behavior. You may want to restrict access to those attributes directly. And the reason is that someone may unintentionally go forward and modify an attribute which you did not wanted anyone else to be able to modify. Plus, you may want to provide behavior methods to indicate what can be modified and how it can be modified. And as those variables are being modified, you may want to keep track on who actually was modifying. For example, let us say you have a class which actually provides interest rates. And in that class, there's a variable which actually reads the current interest rate from our database. Now, you do not want your clients to be able to modify the interest rate that's going to be applied to them, so you want to restrict that access. And even if there are some admin users who can modify the interest rate that's applied, you may want to do some audit trail on who actually modified the interest rate and by how much. And all that is achieved using encapsulation. When you talk about encapsulation, you start thinking about access specifiers. And here's where you're thinking about private and public at a very high level. And private is something which is only visible uh, to variables, functions which are present inside the class. And public is which is available outside to everyone. And then there's default access specifiers as well. Let's look at one of the examples to get a better understanding of how access specifiers work. Now, if you're new to Playground, just a quick note, each playground has its sources and resources folder. The reason for existence of these sources and resources folder is that you can go forward and add code to them that will not be compiled every time the playground is run, but when the file is created. But then you can go forward and separate the code, like you can create classes into separate files like you would actually create in a real life example. Here, what we do is that in an encapsulation example, we'll go forward and create a new file. It will be a Swift file, and we'll, as we're talking about in the example, we just call it interest rate manager. Now we have an interest rate manager which is defined. It's a class. We already said we would be declaring a class interest rate manager. So we did that. Now it's going to have a variable which is going to be the interest rate. And this is my super secret interest rate which I'm going to apply. And let's say 2.4% is the ongoing value, and assume I'm reading it from some database. I'm not going to connect to a database, but assume that I read this value from some DB. Okay, all good and dandy till now. Now, if I go back and say I, as a user, I build this package, I created this library, it has the interest rate manager. I come into my encapsulation class and I say, okay, I am going to try and see what interest rates are available. So I go forward and declare the interest manager, and this time it will give you compile time error because I defined this class with the default scope, which means it's not really visible to anyone outside. So I have to go forward and declare this class as public. Once I declare this class public, again, thinking access specifiers, if I really wanted interest rate manager not to be visible to anyone outside, but only to contents of this file or this group, then I didn't want to make it public. I would have left it as such, and encapsulation can never see that this class existed. This is also encapsulation. I have access to interest rate manager, but anyone outside does not have access to this class. Now I'm still seeing a compile time error. If I go back, there's still a compile time error, which is actually complaining about. And is complaining about the fact that, okay, I still can't access interest rate manager, even though I have made it public. And the reasoning is that even though the class is public, okay, it means that I can see the class, but I need to be able to instantiate the class, and the init method is not public. Now, before I do the init method public, I'm going to specifically mark, sorry, I'm specifically going to mark this variable private because we're talking encapsulation, so I want to be explicit. I can go forward and define my public init, and the public init is going to be do nothing in it. It's already initialized, so I don't need to initialize anything. But now when I go back, this should not be a problem because now the interest rate manager itself is public, has a public initializer, so I can access it. But when I try to go forward and use this variable or the object of interest rate manager, I don't see any variables or attributes or function. The reason is that because the variable is defined private, so I really can't have access to it. I don't even know that it exists. And that's the magic of encapsulation. I can hide how interest rate or whoever has access to interest rate. And the way I do it is that I can go forward and define a public method. So saying get current interest rate, and let's say it's going to return me a double back. Okay, so because it's interest rate, and it's going to store the current rate, which is my interest rate. Because I'm the same class, I've accessed even the private variables. Now, let us say I want to do some computation on top of it. Okay, so I went forward. I can define a new method here. Okay, private, and it will be get shady interest rate. Again, and you don't necessarily need to be doing anything shady inside it, right? It's just trying to indicate that yes, you could be doing some super secret business logic on top of the attributes that you are retrieving from the database before you actually hand over to your clients. And that's what I'm trying to do here. It's also going to return a type double. And all it's doing here is it's going to take the current rate, which we read from the DB, add 1 to it, and return it back. And this guy, our current interest rate, is simply going to go forward and return back the shady rate to whoever calls it. Okay, now I forgot the function keywords, so let me add them, and I'm all set. Now, what's happening here is internally, yes, there are two functions which I have defined. There's get current interest rate, and it's not returning back the interest rate. Now, this is again to go back to the concept of encapsulation. I protected this attribute from being directly accessible to anyone outside. Then I exposed a method and provided access specifier public, and it can now go forward and return back the interest rate. But that's not the exactly same interest rate I'm returning. I'm actually doing some computation on it. So I can apply some business logic on top of it and then return the new value back to the column. Now let's look at what's visible to people who are outside. So I go back to my interest rate manager, I click on it. And when I click on it, I see get current interest rate. Okay, awesome. And I can retrieve the value. So let's run it and I get 3.4 back. If you see, my interest rate was 2.4, but my get shady interest rate was incrementing the interest rate by 1 and then returning the value. So, and that's what I saw here when it executed got 3.4, but I never saw the existence of the other method, which was get shady interest rate, because the access specifier for the shady interest rate was private. It's not visible to anyone outside. And that's all encapsulation is about. Encapsulation is about hiding certain elements which you do not want folks to have direct access to. So we primarily talk about access specifier when we think about encapsulation. Now, computed properties are a bit different, but I'm going to talk about computed properties here itself with encapsulation. And the reasoning here is that they do provide certain level of access. Um, and they allow you to go forward and restrict setting certain properties if you want to. You can actually go forward and define a stored property which can have a setter but no getter. And you can do so with the computed properties having vice versa, getters with no setters, and we're going to see that. Um, and in this example, what I'm doing is that I have a student class, and the student has a name. It's a math score and a science score, and it's a grade. But grade is not like a normal property. Grade is not just like a variable like full name, which is of type annotation string. It is of type string, but at the same point in time, it actually has these curly braces, and that's how you define the computed properties. You put curly braces at the end of the variable that you have defined, and you add getters and setters to it. Now, the way you access the current value of this grade. If the first question people have in the mind is that, okay, what if I want to access the current value of grade? Now it's a computed property. So the current value of grade does not make any sense really here, right? What you want to do is that you want to define the business logic based on which if someone wants to access this property, which is an instance of student dot grade, then what should they get back? And it probably is a result of some business logic that you're conducting. And here I'm doing is that to compute the grade, I'm checking for the prior math scores and science score, and both have to be greater than 90 for you to get an A. For you to get a B, it has to be greater than or equal to 80. In a simplified check, you would think that what is 1 is 95. Yes, 1 can be 95, but it does not really matter. So if both were above 90, you would have already returned A. And then lastly, if none of the above two conditions are met, you get a C back. So returning a type of string, but it really does not have its own value. Now, for demonstration purposes, I put in the set so that I can actually show the set being called. And whenever you call set, the current value is passed into a variable named new value. And that's what I'm just printing. So you didn't specify new value, but it's a new value, and that's what I'm printing here. I went forward and defined the initializer for this class. That's all good. Then I go forward and define my object instance Carlos. His name is Carlos. His math and science scores are 95 and 85. So he's a grade B student. And then I go forward and say Carlos on grade, and then go forward and use grade just like any normal variable. But inside under the hood, it's just not does not know it's B right now, right? Is there no one has assigned it a B grade? So in the hood, it's actually doing the computation. It's saying that 95 is greater than 90, okay, but science score is not greater than 90, so it can't be A. And let's say 95 is greater than 80, so all good there. And 85 is greater than 80, so I am B, and that's what you see here, Carlos on a grade B. Now I did provide a setter. Since I did provide a setter, what you can see is that I can go forward and assign a grade. I went forward and assigned a grade A, and I did see the value getting printed, which is you have chosen to force override the grade to new value. New value is the value which I assigned to this property. But then I go forward and just print the value of Carlos grade, and it's still B. Because again, the computed property is not a stored property. It's not stored anywhere. So as a result, you can't really go forward and hope that you set the value and then the value is reflected. The setter here was just for demonstration purposes. You may want to go forward and simply remove the setter. And now you get a compile time error. You're saying that, okay, well, there is a getter, but there is no setter, so you can't really set the property. Okay, I hope you get the gist of it. Now you can do some complex logic if you want to allow capability of setter. So for example, you can define is, okay, where, okay, forced grade, and it can be of type string, so it's a stored property. And you simply say that, okay, uh, if the force grade is defined, then I'm going to go forward. It's optional, so I don't need to initialize it. I want to say that if let, okay, graded equals forced grade, okay, so if that is the case, that okay, I have a force grade which is defined, I am going to return that force grade back to the caller, else I am going to go forward and execute my existing logic. So otherwise I was going to return back my forced grade. And in the setter, all I would be doing is I'm going to say just like any other place inside the class, I can refer using self force grade equals the new value, whatever I passed. So that would be the way to go forward and refer to the force grade, which I had defined as a new property. So I go forward and use it. Okay. So now of course, I should not have used force grade here. I should have gone forward and used graded because that's the whole purpose of optional binding, and that's what I complained about. But now if I see I'm executing the same piece of code, and at the end of the execution, you see my graded property comes as A. The catch here is that computed properties are not stored properties. So, but you can make them behave like stored properties by, of course, implementing some business logic on your own. But still, computed properties relate to the concept of encapsulation, where you can go forward and even for properties that you're making public and visible to all your clients, you can control whether they can call the getters or setters and so on. And that's all you need to know about encapsulation.